right, today I want to talk about probability. There are a whole lot of things we can say about probability, but this is going to be an introduction. We're going to keep it pretty simple. We're going to keep it brief. If we flip a coin, there are two possibilities, presumably. The coin will either land heads or tails. I guess if you flip it over some muddy ground, it might stick on the edge, right? But we're assuming that either lands on heads or tails. So there are two possibilities, but only one of them can actually happen. We can't get both heads and tails when we flip the coin. So only one of those two possibilities can happen on each coin flip. We say the odds of a heads would be 1 over 2 or 1/2 or 1 in 2. Sometimes it's written as 1:2, but more often than not, we're going to see that written as 1 over 2. One of these two things can happen on each coin flip. What are the odds every time we flip the coin that we're going to get heads? It's 1 out of 2, or 50% chance, or a 50-50 chance. 1 out of 2. And what are the odds we're going to get tails? Also 1 out of 2. There's an equal chance, and we're assuming it's a fair coin. Most coins are not completely fair. If you flip them long enough and test them, you'll discover that you probably get one more often than the other, heads more often than tails, or vice versa. But generally, we assume that a coin is fair. If we roll a die that's a cube that has 6 sides, if you're familiar with dice from a game like Monopoly, you can only get one number every time you roll the die. It could be a 1 or a 2 or a 3 or 4 or 5 or a 6. Those are the only possibilities. There are 6 possibilities. So for each number on the die, every time we roll it, there's a 1 in 6 chance that number will come up. What are the odds if we roll the die, and we're assuming it's a fair die, that we'll get a 1? Well, there's a 1 in 6 chance, which is roughly 16%, something like that. But usually you see probability expressed this way. 1 in 6 chance. There's a 1 out of 6 chance. What are the odds of rolling a 2? Also 1 in 6. What are the odds of rolling a 5? Also 1 in 6. In fact, the odds of rolling a 1 are 1 in 6, and the odds of rolling a 2 are 1 in 6, and a 3, and a 4, and a 5, and a 6, and we add them all up together. We get 6 out of 6. And 6 out of 6 just equals 1. Because the odds of anything happening, if you add up all of the different possibilities, they should equal 1. That's the way it usually works. That's why we say that there's a 50-50 chance of some things happening. 50%. Well, 50% plus 50% equals 100%, which is 1. Just one whole. There are lots of things we might try to predict that are more difficult to predict. Like if there are 12 horses running in a race, and only one of them can win, what are the odds that any one horse will win the race? Here's a hint, it's not 1 in 12. Because each horse has different abilities, and so each horse has different odds of winning the race. Some horses are a long shot. They have a 1 in 20 chance of winning. And some horses have a really good chance of winning, like 1 out of 2. So that's not a real fair contest. It's not like rolling a coin or flipping a die. Because each horse does not have an equal chance of winning the race. So you usually won't be given an example like that. In math class, they're almost always interested in something in which each possibility has an equal chance of happening, like flipping a coin or rolling a die. Those are the big examples you usually get. Sometimes they'll say, well, what are the odds of rolling an even number on a die? Well, if a die has If a die has 6 numbers, which ones are even? The 2, the 4, and the 6. 3 out of the 6 numbers are even. And by the way, those are the odds of rolling an even number. 3 out of 6, or 1 out of 2, 1/2, because 3/6 and 1/2 are the same thing. It's a 50-50 chance. And the odds of rolling an odd number are also 50%, or 1 in 2, or 1/2. There you go. And if we add them up together, we get 1. 1/2 plus 1/2 equals 1. Should we make it more complicated or leave it there?
How would you make it more complicated?
Well, we could talk about the probability. This is some advanced stuff. The probability of getting a certain result on more than one coin flip or more than one roll. For instance, if we flip the coin twice, what are the possibilities of getting 2 heads in a row? Getting heads on the first time is a 1 in 2 chance.
Mm-hmm.
Getting heads the second time is also a 1 in 2 chance.
Mm-hmm.
1 times 1 equals 1. 2 times 2 equals 4. There's only a 1 in 4 chance of getting heads twice in a row, or tails twice in a row. And you can keep going. What are the odds of getting heads 3 times in a row? Well, we multiply by 1/2 again, and it's only 1 in 8. It doesn't happen very often. And then 1 in 16 and 1 in 32 and so on. And if you want to get really complicated, you introduce the dice.
Yeah.
What are the odds of rolling a 12 on 2 dice? 2 6-sided dice. Well, they both have to be 6s.
Mm-hmm.
And there's only a 1 in 6 chance of rolling a 6 on the first die. And there's only a 1 in 6 chance of rolling a 6 on the second die. 1 times 1 is 1, and 6 times 6 is 36. Out of 36 rolls of a couple of fair dice, you would only expect to get a 12 once. It doesn't happen very often. So if you're playing a game like Monopoly and you're counting on getting a 12 on those 2 dice, good luck. It doesn't happen very often.
Neato.